Okay, so Roman numeral 1 is just a review for electrophile addition across an asymmetric carbon-carbon double bond. So I'm going to start at Roman numeral 2, and it says complete the following mechanism by adding the arrows, the cation, halide anion, and the final product. Label all nucleophiles and electrophiles in the reaction. Okay, so I'm going to go ahead and take electrons from the double bond, bring them over to the hydrogen, and the electrons from that bond that breaks go to the bromine, and we're going to get this cation and a bromine anion. And for the next reaction, the bromine's going to come in right there, and you're going to get this molecule. Okay, so Roman numeral 3 says give the structure of the, okay, so in this reaction, this is the nucleophile, this is the electrophile, okay, and then here, this is the nucleophile, and this is the electrophile. Alright. Okay, and then so for Roman numeral 3 it says give the structure of the alkenes that upon reaction with HBr would yield predominantly the products shown below. Okay, the only alkene that would yield both of these products would be this one here. Alright, and then so for Roman numeral 4 it says give the mechanism and provide the products formed for each of the following reactions. Okay, so for this reaction right here, the electrons would come into the hydrogen, and the bond between the hydrogen and iodine would go to the iodine. And then you would get these two products. Alright, and then for the next reaction, the iodine would come in right here. And you would get that right there. Okay, and then for this reaction here, the electrons from there would go to the hydrogen, and the bond between the hydrogen and the bromine, the electrons would go to the bromine, and you would get the cation here, and the bromine anion. For the next reaction, the bromine would come in here, and you would have something kind of like that. Alright, and for the last one, it's about stereochemistry of electrophilic addition to the carbon-carbon double bond. So for the following reaction, draw the two stereoisomers that are formed and designate the configuration for each isomer. Okay, so for this reaction, these electrons would come here, the ones from the bond would go to the bromine, and you would have, oh my goodness. Okay. You would have a cation here, plus a bromine anion. The anion would come in here, and you would have something that looked somewhat like this. Okay, and then the two stereoisomers would be these would be the two stereoisomers. Alright, so the configuration for each of these, I'm going to label the carbons going from left to right. So we're going to say that this up here is CH2, CH3. This is CH2, CH2, CH3. Okay, this over here is going to be the bromine, and this is going to be H3C. Okay, that's top priority, that's last, that's second, and that's third. So you go around clockwise, and then you cross the low priority on a dark wedge. So it's actually counterclockwise, so this is the S configuration. Okay, and then here we're going to have CH2, CH3, and CH2, CH2, CH3. We're going to have HC3C over here and bromine over here. So that's 1, 4, 2, 3, and you're going to go around counterclockwise, but you cross the low priority on a dark wedge over here. So that's actually going to be clockwise, so that's the R.